Uh, Now it's 5 o'clock. First and foremost, allow me to welcome the learners, the educators, the parents, and all the stakeholders in the education fraternity. We are here a historically moment in the KZN Department of Education, whereby we have got our own first class of virtual class in trying to make sure that wherever you are, quality education is accessible. We are not theorizing the 21st century still. We are breaking the barriers in terms of the location. Where you are, it doesn't matter today, because here we are with the virtual classes, whereby we are going to make sure that equal opportunity for all learners are being met. We would like to appreciate the KZN Department of Education with such historically initiative, whereby our learners are going to access quality education, where excellence is not about the theory, but it is indeed realized. This is the new era in our teaching and learning, whereby platform to support our learners to master the concept through conceptual understanding, to make sure that all the learners, the gaps that they have in mathematics are being closed. And then we are here to offer the quality teaching and learning of our KZN student. We have to make sure that we prepare our learners for their assessment, as we are going to have our cohort sitting for their assessment May, June examination, the final examination. We are here to say, welcome to the first ever virtual initiative in our education fraternity. Here is the subject called mathematics. We are going to start our virtual classes with mathematics, because mathematics is not just a subject. It is the only subject that is a universal language. You go to any country across the globe, mathematics is understood. So it is not only just a subject, but it is the foundation for science and technology. It is the subject that assists the student to critically think, to critically engage and develop the solving problem skills. Mathematics is not just a subject, but it's also a gateway subject which seeks to assist the student with their career path when it comes to the education sector. We are going to make sure that as we engage with different students across the province, also outside of the province, you are more than welcome to come and join, as we will be engaging in our teaching and learning via virtual platform. It is not only mathematics that is going to be offered via these virtual classes. We are also expecting to have subjects like physical sciences. Your accounting will be offered. Your life sciences, your English, your history, and geography will be offered via this platform to make sure that in KZN, all the students access quality learning, excellent teaching, and they maximize their potential to succeed in life. Not only because those who were then privy to access quality education, but the Department of Education has taken a stance to make sure that everywhere where you are, irrespective of the location, being in rural areas, in township, in suburb, here is your platform to learn. We are then inviting everyone to make sure that at 5 o'clock, you log on into your Microsoft Teams, whereby the town hall platform will accommodate everyone. Collaborative, we can actually assist our students. Allow me then to invite my colleague, Mr. Nzama, whom we will be dealing with in trying to make sure that mathematics is accessible for everyone. Over to you, Mr. Nzama. Thank you very much.
Thank you very much, Mr. Ntuli. By the way, this is Mr. Samkelo Ntuli, who was just making a presentation just now. I don't remember you introducing yourself. So, Mr. Ntuli and I will be working collaboratively in making sure that we deliver these mathematics classes that he's been talking about. First and foremost, it is important to take note that teamwork and collaboration goes a very long way. That's why we are going to be taking you through together with Mr. Ntuli. We are going to be working interchangeably in delivering these classes of mathematics. But we all know that mathematics is one of the most feared subjects in the country, if not in the entire world. And these fears, they come from the gaps in knowledge. They come from the lack of understanding. So ours, as these educators who are going to be taking our students in mathematics, is to make sure that we simplify. We try to make sure that we make mathematics enjoyable and very fun to our students. These fears come from the lack of practice. They also come from the lack of understanding in terms of the concepts, in terms of the content behind mathematics. So consistency is the key. So what we are going to be doing today, we are going to be taking you through mathematics each and every step of the way. We encourage our learners to make sure that they attend these classes on a regular basis. We also encourage our learners to make sure that they participate actively. They have to ask questions. There is a comment section where our learners will be able to ask questions, and then we are going to make sure that we answer them appropriately. So before I hand it over to Mr. Ntuli to take us through our first lesson, because we will be doing our first topic for today, but Mr. Ntuli will take us through what is it that we are going to be doing. I'm sure our students back at home, they can't wait to hear their first lesson. So we also encourage our parents to make sure that they make sure that these resources become available to students. We want to make sure our students are able to attend the classes on each and every day, each and every lesson. For that to happen, these students, they need to have data, they need to have cell phones. So let us make sure that we provide them with this assistance so that they will be able to attend our classes. We also agree with the saying that says success in mathematics is not reserved for the gifted, but it is for the committed ones. Over to you, Mr. Ntu.
No, thank you very much, Osiane, for this opportunity. As Mr. Nzama has alluded, student at home, you have got a platform for Q&A session, whereby you will be writing all your questions and make it a point that on your Q&A lapha ekhaya kukhona link embedwe kwi-Q&A platform. Make it a point that kuleyo link leyo uyalenza isiqinisekiso sokuthi uyaregister usho ukuthi I am student so and so according to the questions that are on the link. We fill that questionnaire to indicate that today you didn't miss the part, which is very important and exciting. So let us go now straight to our ground to play our mathematics. And this is nothing except what? The idea hub. Now, what is it that we are going to do? Allow us first, learners, to go through the examination guidelines esilekelela kakhulu uku-understanda ama-weightings of our chapters. So ngaleyo ndlela leyo, it will then assist us to understand ukuthi ama-weighting of each and every chapter and each and every question amkanjani. We all know ukuthi we have got two papers in mathematics, and that is paper 1 and paper 2. Each paper, it consists of 150 marks for 3 hours. Now, we have got 10 chapters that we need to look at. We have got 1, the number pattern and sequence, the financial growth and decay, functions and graphs, what we are going to focus on today. We have got algebra and equation differential, calculus, and probability. We have got also Euclidean geometry and analytical geometry, statistics and regression, and trigonometry, which actually, those are the chapters for paper 2. Now, with that, we are then saying, let us go straight to the examination guidelines. On our examination guidelines, as we have seen that, marks for each and every chapter. The functions and graphs that we'll be doing today, they amount for 35 marks. Osiane, I tend to differ with this submission to say, student, the graphs and functions amount to 35 marks. Why am I differ to this one? This will be only questions specifically asking 35 marks. and that will be plus or minus 35 marks. But let us go to each and every question. When we go to each and every question, to each and every chapter, I will do this in the form of a formula sheet so that I'm able to summarize it. If we go to the first one, it speaks to the quadratic equation. This quadratic equation, as the word says, quadratic, it speaks to the quadratic function. And when we talk about the quadratic function, that is parabola. Which means as you are dealing with quadratic equation, you are dealing with functions in the form of parabola. If you go to financial maths, this one is a simple interest formula for appreciation and this one for depreciation. This is a compound formula for depreciation and this is a compound for appreciation. Now, when we look at these questions, this formula, learner, I know highest degree of 2, the exponent is not 2. And when you look very closely to this one, it speaks to the straight line. And when you come to this one, it has got the exponent. What then does it mean to us? It relates to exponential functions. Then when you go to this arithmetic series formula, again, it speaks to what? The linear, also linear equations, which is a linear function as well. Again, when you go to the geometric sequence formula, this is exponential in behavior. Also, the derivative of this geometric series formula, this is derived from the addition of the sequence, which becomes a series. But that sequence is for what? It is for the very same geometric sequence, which is exponential in nature. So it is on those bases I'm saying, yes, we are talking about functions and equations which amount to 35 marks, plus or minus. But the reality is, when you go to mathematics, there is curricular integration or content integration, which speaks to that. And then when you go to geometry in the form of analytical geometry, this one is an equation of a straight line. This one is an equation of a straight line, which is dealt in functions. This one is a gradient, and also here, an angle of inclination. So in short, I'm saying functions and inverses, they are not actually contributing only 35 marks when you are writing mathematics because they cut across. So it is that our submission to say, please, as today we will be engaging on functions, it is on those bases. Let us start with graphs and functions as our basis of our mathematics lesson because of the content it has on each and every question and each and every chapter. There is that curricular integration. I hope and I want to believe that we are all together on that one. Now, I'm getting into our presentation. So in our presentation, as I've alluded with my partner in crime, Mr. Osia, we will be focusing on functions as it has been indicated. According to the examination guidelines, they amount 35 plus or minus 35 marks. So here we've got the misconception that were indicated by our previous examinations reports, that the learners, as they are writing their examination, the domain and the range are very important, especially for exponential, because that's where the learners, they make their mistakes. Also in hyperbolic graphs, sketching the hyperbola, asymptotes were not labeled, graphs crossing the asymptote line, coordinate of the reflected graphs, range in the parabola, whereby they were excluding the minimum and the maximum values. So all these were actually reported. So how then we are going to look at our approach? Our approach will be on an interpretative part of our parabola, whereby we look at each and every parameter learners and its effect on the graph. That is very important. Therefore, we are going to embrace our technology to go through the parameters of the parabola. As we all know that a vertex form, it is made of y equals to a into x plus p all squared plus q. That is a vertex form because it gives us the coordinate of the turning point, which sometimes it's called the vertex point. What we are going to use to do that, we are going to dive deep into what we term first simulation. In our first simulation, then, I will be taking you through the effect of each and every parameter on the parabolic graph, which is the main graph that will explain all the transformation that undertaken by each and every graph. So, as we all can see, this is the general form in the form of y equals to a into x. Here it says minus h all squared plus q because this is a programmed assimilation that we'll be using in order to understand the transformation. Whereby a, as if you can go there, our a in that equation, still it is the very same a on the other formula that we will be talking about here. So let us look at a and its effect. There are things that we need to understand before we attempt each and every question about the parameters. And learners, ekhaya lapha enikhona, ngicela ningithathele lokhu ke manje. U-A that we see on graphs affect the graph, all of them the same way. So this A, when you go to hyperbola, when you go to parabola, when you go to exponential, when you go to tree graphs, is behaving the same way. I would like us to look at A if it's 1. The graph is concave up. This graph, as it is concave up, what it has got the vertex point, which is the turning point. Our graph turns at 0.00 as it is the matter graph. The very same graph has got what? Le graph le masibheka in the axis of symmetry. Yini axis of symmetry? Ngani yakethu. Ngani yami, axis of symmetry is that value which forms a vertical line in parabola. It can be also a horizontal line in other graphs, such as what? Such as a hyperbola, and also a exponential. So in this context, a parabola, the axis of symmetry will then divide the graph into two equal halves. Negama liyazisho-ke la ngane yakethu. La ngane yami igama malithi axis of symmetry lichaza ukuthi what is on the left is exactly, if you flip, will fall over exactly on what is on the right. So that one then, it's what will define the axis of symmetry. In this context of a parabola, is a value that will make the graph of a parabola to be divided into two equal halves. That will be an axis of symmetry. Let us go then to a value of A affecting the graph. If our value of A is greater than 1, you can see the graph. The graph will be vertically elongated. It stretches vertically. Lokhu ke ngane yakithi kwenzakala kuwonke amagraph. Ukuthi uma nje ivalue ka A is greater than 1, amagraph ayaluleka vertically, meaning lokho ku-affecta yonke igraph, because igraph negraph isuke representa i-behavior yama-values ka-y. So as you can see, masi increase about 3 value of A, igraph yethu it's getting closer to y-axis and elongate vertically. These squares are in 1 unit. So you will see that one on this board, that these squares are in 1 unit. What then will happen if our A is not equal to 1? The graph will not define a parabola. It will be a horizontal straight line. Now, kwenzakalani uma ivalue ka A is less than 0? By less than 0 meaning isi-negative, sincane kuno-0. Igraph yethu iyashintsha from concave up to concave down. Yini into ebalekile okumele uyi-understand la ngane yami. Kumele ukwazi ukudefine i-transformation that undertaken by a graph from being concave up to concave down. So therefore, the type of transformation undertaken by this graph, it is a reflection across the x-axis. Kusho ukuthini lokho? Kusho ukuthi wonke ama-values ka-y for each and every graph that exists will change their sign. Otherwise, njengamanje wonke ama-values except lo 0 ngoba kwi-point of origin neutral, wonke sitha negative. What makes all the values ukuthi abe negative? Ile value of a eshintshile. Now, I will say this because our simulation does not allow us to actually assimilate that one. Then kuzokwenzakalani uma i-value ka a is greater than 0 but e less than 1? What do I mean by that? E-fraction. If value ka a is greater than 0 but e less than 1, as a fraction, i-graph yethu will shrink, izocompressa, isondele kuma x-axis, which is the opposite ukuthi ma greater than 1 iyaluleka isondele kuphi na kuma y-axis. Kulaleleka ukuqaphelisiseke lokhu. Lokhu kwenzakala kuwo wonke ama-graph enizobhala ngawo, including your hyperbola, your parabola, your three graphs, kwenzakala into eyodwa. Now ngifisa ukuthi ke sihambe siyobuka ke manje i-effect ka h in this case, but on our normal formula kuzobe ku-p, which normally used. Ngiye ngithi ke mina kuma learners ungayenzi mistake yokumera with i-symbol or i-letter. Okubaleke kakhulu uku-understanda i-pattern ye-formula. They can put any letter. It will then assist you ukuthi now udila nayiphi i-formula. So lokho kubaleke kakhulu ke ngane zami. Ingakho ke namanje ngithi lo h ubehave the same way as u-p on our normal textbook. Now, njengamanje u-h wethu ngu-0 and i-graph yethu itena kwi-point of origin. Let us see ukuthi kwenzakalani uma i-graph yethu ishintsha. Ngaphambi kokuba ngi-effect u-h in this case, kubaleke kakhulu ukuthi ngikusho ukuthi le formula ibuyaphi. Le formula ibuya from ekucompleteni what we termed ukucomplete i-square. So masiyibambe lapho singeke ke sibe nenkinga yoku-understand ukuthi le formula ibuyaphi. Ngoba le formula ngoba injena nje i-y equals to a into x plus b over u2a. Sithola lokhu masikade sicomplete i-square. So lo p lo usuke edefine i-axis of symmetry. What then does it mean? On the graph, i-axis of symmetry yenza lokhu ke ngane yami. Iqale i-affecte i-graph yethu, imuvisa i-graph yethu. Imuvisa kanjani? Imuvisa along the x-axis. Then mathematically sibe sesithini ke sithi it's reflect across, it's shift along the x-axis, meaning it's a horizontal shift, or it's a horizontal movement, or it's a horizontal translation. So those are the terminology that we use. Now, when we go to that one then, we want to see how change in h will affect the parabola yethu. Uma u-h engu-1, but lower negative, it's for the formula. Please don't get confused on that one. Nibonile yini ukuthi igraph yethu isuke kuphi kwi-point of origin ya shifter 1 unit to the right. Ingoba lapha u-h usewubani? Use u-negative 1 if umrada in conjunction with i-formula yonke. So ake sibuke maye u-negative 2. So igraph yethu again iyasuka kwi-point of origin iyashifta. Ngaba ama-values ka-y anayo effect, it's only affect ama-values ka-x. Since u-x ke determinant, independent, that will have an impact on the position of the corresponding y value. So yilokho-ke kumele sikunothise kakhulu ukuthi that h, it works with a horizontal shift. Afterwards, that horizontal shift, it becomes an x turning point. There are two things okumele siyinake lapho. It first shifted left or right. After it has shifted it, ibe isiphenduka ini na i-x coordinate of the turning point, which will then also give us a y coordinate of the turning point. Ake sibone uma i-value kabani na ka-h now you-1. So with this one, u-negative times negative will give us ubani u-positive. Sirida kanjani-ke manje equation yethu? I-equation yethu now sizobe sithini-ke y is equal to negative into x plus 1 all squared. What's happened to the graph? The graph will then shift from the point of origin to the left. Because of ubani because plus 1, because negative times negative ubani positive kuma integers. So kwenzakalani uma seku u2? Since la kuzobe seku positive 2, our graph u2 effect will shift it from the origin 2 units to the left. That's how we must present ourselves. So we then go to banana. We go to UK in this case. But in our normal books, normally they use ubani uq. Look at the position. It is exact the same way. So what is important? It is also the pattern how the equation or the formula is presented to us. Okubalulekile ke manje ukubuka ukuthi k in this example increase noma decrease kwenzakalani kwegraph ngoba umfundi waka-matric kulindeleke ukuthi akwazi uku-explain and akudefine lokho. Yilokho kubaluleke kakhulu uma siwenza u-matric. Now ake sibukeke u-k wethu uma sewubani esengu-1. How? I-graph yethu iqale yashifta from the point of origin. It shifted how many units? Let us learn to be specific. It shifted 1, 2 units to the left. Ubani okhoze lokho? U-negative times negative kwaphuma positive 2. Now we are saying if x plus 2 all squared, kwenzani lokho egraphini? It will translate our graph 2 units to the left. Plus 1, which we also get by completing a square. That plus 1 ube seba nayipi effect. That plus 1 ube se shifter, a translator, a mover, igraph yethu from y equal to 0, because on the x-axis i-value ka-y is 0 because it's defined the x value which are the independent. It shifted how many units? It shifted 1 unit. Now, ake sibuke uma u-q wethu or u-k wethu engu-3. I-graph yet again on y values, it shifted how many units? It shifted 1, 2, 3. Therefore, our point of a turning point, the coordinate of the turning point, is sesini kwa ubani. Sizonika negative 2 and 3. Learners, please be careful of this, the language of mathematics. Sometimes we will make mistake to say this is negative 2 is to 0. Mathematically, that is a ratio when you say is 2. So the way we should read our coordinate is x and y. Or it's easy to say x maps y. So it's negative 2 and 3, which will be then our coordinate of the turning point. Now, let us look what will then happen if we change our value of a. Do you see now our value of a is positive? Then the graph will be concave up. Kusho ukuthini? As umfundi waka-matric, uma nje uye wabona this equation, kumele ukwazi ukukhuluma i-transformation eyenziwe ile graph. This graph, since a greater than 0, will be concave up. U2, njengoba kuno plus 2 la, it means that from the point of origin on the x values, it will shift 2 units to the left. Bese kuthi u3, u3 njengoba positive, it means on the graph, on y values, it will shift 3 units up. Ngiyaphinda grade 12. Konke lokhu kwenzakala kuwo wonke amagraph esiwafundayo ebangeni leshumi. So ke le introduction kumele isilekelele to understand ukuthi kwenzakalani. Okunye ngicela ukuthi ngikudlulise kuyo le transformation, i-issue ye reflection of a point. So I will just take igraph yethu back to a point of origin as a turning point. Ngiyobe sengicela ubaba uNzama ukuthi aphinde aqhubeke. Ngizosebenzisa isibonelo lapha sika coordinate ubani? U2 and u4. This is the square where the line meet, 2 and 4 the coordinate here. Kwenzakalani uma si reflector igraph yethu across the x-axis? Ilokho kumele sikwazi ukubamba. Igraph yethu i-distance from uline reflector ngawo will be exact equal naleli point elikade li reflector. Ngisho ukuthini na? Asikubukeke. Uma ngisuka ku2 ngiya ku4 on the x values, kuyafana nokusuka ku2 ngiya ku -4 on the y values. So kusho ukuthini? The line osuku reflecte ngawo becomes the mirror image of a reflected point. The coordinate initially, it was 2 and 4. But if we reflect across the x-axis, the new coordinate will be still ubani? U2 and -4. So hilokho kubalekile bengifisa ukudlulisa to understand the transformation code. That also be part that we need to understand. Now, isikhathi it's 17:32. I will allow my colleague, Mr. Nzama, to take us through different types of activities whereby we will be applying the very same transformation across all the graphs that we'll be dealing with in paper 1. Over to you, Mr. Nzama. Thank you very much. I hope and believe you are still enjoying what is being presented to us. Thank you.
Thanks, Mr. Ntuli. We are going to be now trying to focus on the activities. Mr. Ntuli has assisted us in interpreting what we call the graph of a parabola, a parabolic function. So we are going to start with this activity. Here, as I'm trying to show you the question, here is our first activity. So our first activity will be to sketch the parabolic functions. Number one, we have been taken through a parabolic function that is in a form of a turning point, which gives us the turning point. So we call it a vertex form or a turning point form. If you look at this equation here, we are given equation g of x equals to x minus 2 all squared minus 4. Maybe before we start on sketching a parabola, the first thing that we should take note of is that for each and every graph, there are different characteristics. Because we are talking about a parabola for now, I am going to take you through the characteristics of a parabola. What makes a parabolic function? Number one, a parabolic function, we know that a parabolic function can take this shape. It's either it is concaved up or it is concaved down. When A is positive, when A is greater than 0, our graph will take that shape. It will be concaved up. Other teachers will say the graph is happy. When A is greater than 0, our graph will be happy. It will be concaved up when A is positive. But what happens when A is less than 0? When A is negative, is less than 0, then our graph will be facing downwards. So it has a sad face. We say it's frowning. So this is how you look at these two graphs. In fact, the other one has A that is greater than 0, and this one here has A that is less than 0. So when A is greater than 0, the graph will be concave up, and when A is less than 0, the graph will be concave down. So that is number one, the shape of the graph. The shape of the graph is determined by the value of A when you are talking about a parabola. So it's important to take note in our given equation here that the value of A that we are given is equals to 1. There is 1 there. Our A is 1, which is positive 1. And when A is greater than 0, then we know the shape of the graph. So we have 1, A is positive, so therefore the graph will be concaved up. Now, number two, what we need to determine in order for us to be able to sketch this graph, we need now to determine the x-intercept as well as the y-intercept. So we need to determine the x-intercept as well as the y-intercept. Now, some of you maybe will be asking yourselves, what is an x-intercept and what is a y-intercept? What is it that Mr. Nzama is now talking about? So we'll go on a Cartesian plane. When you go to a Cartesian plane, you have your y-axis. You also have your x-axis. Now, going to in a Cartesian plane, then we are now going to say each and every point that will appear on the x-axis, if you have a point along this line, along the x-axis, then that point is called the x-intercept. It's where the graph intersects with the x-axis. So it's called the x-intercept. Now, for a parabolic function, we know that we are expecting at least two x-intercept. So if you have x-intercept, two x-intercepts, then you plot those points on the x-axis. We know that on the x-axis, y is always equals to 0. So the other name for this line, for x-axis, is line y equals to 0, because y is always 0 along this line. Y is always 0 along this line. So the other name for this line is line y equals to 0. What about the x-axis? Again, on the x-axis, x is always 0. So when x is always 0, then we can name this line x equals to 0. So when you move along the y-axis, x is always equals to 0. That is very important to note, because when we are talking about the x-intercept, then you'll understand when we calculate the x-intercept, when we are looking for x-intercept of a parabolic function, we then say y is equals to 0. So we go to our equation, and where there is y, we put 0, because on the x-axis, line y is equals to 0. So let us calculate the x-intercept then. Our equation, which is g, which is y equals to x minus 2 all squared minus 4. So because we want to sketch a parabolic function and we are looking for the x-intercept, then we said on the x-axis, y is always equals to 0. So let us now equate it to 0, and then we have x minus 2 all squared minus 4. So where does this 0 come from? This 0 comes from this line, which is y equals to 0. We said y is always 0 on this line. So because the x-intercepts are points that are found on x-axis, therefore we need to equate it to 0. And then after that, we then have to solve for x. How then do we solve for x? We then have to simplify x minus 2 all squared. When you simplify x minus 2 all squared, it will give you x squared and then it will also give you negative 4x, then it will give you plus 4 minus 4. So that is 2x minus 2 all squared simplified. It's x squared minus 4x plus 4 minus 4. Some will want to expand the brackets and then use the FOIL method then to simplify. And then after that, you will be left with x squared minus 4x, as positive 4 minus 4 will give us 0. We then have our equation as x squared minus 4x. And we can all see that now this is now a quadratic equation, but we only have two terms and there is a common factor. So ours now is to do what then? Is to take out the highest common factor, which is x, and then it will be x into x minus 4 equals to 0. And then if we have two factors which are equated to 0, then we know we apply the zero factor law. Therefore, x is equals to 0, or x minus 4 equals to 0. Then it means x is equals to 4. So we now have our x-intercept as 0. We also have another x-intercept as 4. We are then now going to look for the y-intercept. And we know for y-intercept again, because y-intercept is found along the y-axis, where x is equals to 0, because along this line, x is always equals to 0. So it is important to note that when you are looking for a y-intercept, you go straight to your equation again and substitute to 0 where there's x, because y-intercept, x is always equals to 0. So again, we are also going to do the very same thing. We will go to our equation. On our equation, what we are going to do, we are going to substitute. We are going to substitute 0. Where there is x, we are going to substitute 0. Say 0 minus 2 all squared minus 4, because we are looking for the y-intercept. So for y-intercept, x is equals to 0. And then what we are going to do is that we are going to simplify this. 0 minus 2 all squared, that should give us 4, and 4 minus 4 should give us 0. So 4 minus 4 is 0. Therefore, our y-intercept is 0. And then it means we have a point, x is 0, as well as y is also 0. So we now have our x-intercepts. We also have our y-intercept. We also know the shape of the graph, because we understand that when a is positive, then our graph should be concaved up. So what is left now is what Mr. Ntuli already told us, that if we are given an equation of a parabola in a vertex form, already we have our vertex. So already we have our turning point. Ours is to write down the turning point. We are not going to calculate the turning point, but what we are going to do is that we are going to write down the turning point, because it's there in our equation. Now let us go back to our equation then and check what is our turning point. So in our equation, the turning point is given by the value of P as well as the value of Q. So we have x minus 2, which gives us P. So we are going to take that x minus 2 equated to 0 and then solve, and then we get x equals to 2. So the value of a turning point for x is positive 2. So the sign will always contradict what is inside the bracket. Since you have x minus 2, then it means your value of x of the turning point is 2, not negative 2. You have x minus 2 inside the bracket. Then for us to get the equation, because this is also the equation of symmetry, we then equate it to 0 and solve x. So our value of x of the turning point is 2. And then the value of y of the turning point is always the value of q. zoomed in. So the value of y is always q. The turning point, the value of y is -4. I think Mr. Ntuli did explain that earlier. So the value of y should be -4. So our turning point then becomes 2 as well as -4. So we are good to go now. We can sketch our graph because we have everything that we needed. We have the x-intercept, we have the y-intercept, and now we also have the turning point. And then ours now is to plot the graph. Ours is to plot the graph now. We have all the information. We are just left with plotting the graph. Okay, so firstly, our y-intercept, we said it's 0 and 0. So we are going to have a point here on our origin, which is 0 and 0. And then the x-intercept, the other x-intercept was 0 and 0. And then the other x-intercept, the coordinate, it's 4 as well as 0. So we have another point here, 4. And then we also have our y-intercept. Okay, we said the y-intercept is 0. We also have our turning point. Then our turning point, we said the coordinates of the turning point are 2 as well as -4. So our x is 2, and then our y is -4. And then we are good to go. We just sketch our graph, which is concaved up. And then after sketching our graph, we then must indicate all the points, x-axis, y-axis, as well as our turning point. So our turning point is 2 and -4. And then our x-intercept is 0 and 0, as well as 4 and 0. So we have now sketched our parabolic function, which was given in a form of a vertex or in a form of a turning point. Our equation, which was g equals to x minus 2 all squared minus 4. So it is important to take note that when you are sketching the graph, whenever you are sketching the graph, then you must know the characteristics of that particular graph. We know for a parabola that we must calculate the x-intercept, we must also calculate the y-intercept, as well as our turning point. But here we did not have to calculate the turning point because the equation was already given in a vertex form. So we just had to write our turning point and sketch our graph. There is another equation which is given as g of x, number 2 on our activity. We are doing number 2 together on our activity. The equation here is saying g of x equals to minus x squared minus 2x plus 8. So that is our equation. But you can note that this equation now is no longer given in that form. The equation is no longer given in a turning point form. You can see these two equations are in different forms. The other one is in a form of ax squared plus bx plus c, which is our standard form of a quadratic equation. So we know a parabola, it's a quadratic graph, it's a quadratic function. So we are given this graph now, we must sketch this graph which is given in a quadratic form, in a general standard quadratic form, which is ax squared plus bx plus c. What is important to take note of this type of an equation is that the value of c, our constant, is the y-intercept. So here we don't calculate y-intercept if it is given in that form. If it is given in a quadratic form, there is no need for us to calculate the y-intercept because the value of c becomes our y-intercept. So our value of c in this equation, our constant is 8. So we already know the y-intercept for this graph that we're about to sketch. We already know the y-intercept. Now, what is left for us is to calculate the x-intercept and also to calculate the turning point. The value of A already, it is given as -1. So it means we know the shape of the graph. It's going to be concave down because we said A determines the shape of the graph. If A is positive or if A is greater than 0, the graph will be concaved up. But if A is negative or A is less than 0, the graph will then be concave down. So it means here we already know the shape. You don't calculate shape. You know shape by the value of A. You only calculate the y-intercept and the x-intercept. But in this form, there is no need to calculate the y-intercept. But I know others would want to calculate. Then if you want to calculate the y-intercept, then you will have to substitute 0 where there is x, and then you are going to get that constant, obviously, because anything times 0 will give you 0. Anything times 0 will give you 0, and then you will be left with 8. So let us now do our calculations so that we can sketch the graph which is in this form. Our y-intercept, as I said, our y-intercept is 8. So we know for a y-intercept, x is always 0 because the y-intercept is found along the y-axis where x is always equal to 0. So we know x is 0 and y is 8. So that should be our y-intercept. Now, let us calculate the x-intercept then. Again, the x-intercept, it's a point that will be found along the x-axis. If a point is found along the x-axis, should x, y, we already know the value of y because this line, I said this line is line y equal to 0. Anything that is found on this line, y will always be 0. So that's why when we are going to be calculating the x-intercept, we'll then have to substitute y as 0. Now, let us do it. Let us now calculate the x-intercept. Our equation, which is this one, g of x equals to, then where there is y, we are going to put 0. That's why we have 0 equals to minus x squared minus 2x plus 8. So we have now equated our graph to 0 because we know where x, where we want the x-intercept, it's where y is equals to 0. And then ours now is to factorize this expression or this equation. Now, how then do we go about it? We have a which is negative. It is always wise. It is always wise to change that negative sign that is with a there when you are now about to factorize. It makes things simple for you if you remove that negative sign. By doing what? By then you can then do that by doing what? By dividing our equation, all the terms by -1. And then if you do that, then you will then be able to remove that negative. Then you will be having x squared, and then you will also be having plus, because when you divide -2x divided by -1, it will change to a positive 2x. And then your 8, which was positive, because positive divided by negative will change then to a -8. Shown up, mention. Okay, and then we then have now we have to factorize. Then we have to factorize. We need the factors of 8. We know the factors of 8 are 1, 2, 4, and 8. So we need the factors of 8 that when we are going to multiply them, those two factors must give us 8. And when we add or subtract, then they must give us 2. And we know those factors are 4 as well as 2. Because when you multiply 4 by 2, it will give you 8. But when you subtract 2 from 4, it will also give you 2. So the correct factors should be x and 4 as well as x and 4. Then because our last term is negative. Our last term is negative, so it means the signs inside the bracket will not be the same. And since our middle term is the positive one, so then the positive will go to a bigger number, and then we'll have x minus x plus 4 into x minus 2. And then we are going to apply the zero factor law, because when you multiply a times b, for you to get 0, then a must be equal to 0 or b must be equal to 0. So that's why we are now applying the zero factor law. X plus 4 is equal to 0, or x minus 2 equals to 0. Therefore, our x is equals to -4, or x is equals to 2. So we now have our x-intercept. X is equals to -4, or x is equals to +2. Then we are now left with the turning point. So it means now we have now calculated our x-intercept, and then we are now going to be able to calculate the turning point, and then after that we'll sketch our graph. We are only left with the turning point. Remember, in this form that we are now given, we are given a standard form of a quadratic, so we have to calculate the turning point. Unlike in the first example where we were given in a turning point form, we didn't have to calculate the turning point, but this time around we have to calculate the turning point because we are not given in a vertex form. So our given equation, remember, was -x² minus 2x plus 8. So we were given this type of equation. Then now what we need to do is what? What we need to do, we need to calculate the turning point. Now, to calculate the turning point, if you are given in this form, then we use the equation of symmetry. We use the equation of symmetry, which is x equals to minus b over 2a. So we use the equation of symmetry to calculate the x value of a turning point. Remember, the x value of a turning point also becomes our equation of symmetry, because where the line that will cut the parabola into two equal parts will be the line that will pass through the turning point. So this is our equation of symmetry formula. We use it to calculate the x value of a turning point. So we are now just going to substitute, because we said this is in a form of ax² plus bx plus c. So it means our b is -2. So it's -2 over 2a. Then our a is -1. Then when you simplify this, negative times negative, it will give you +2 divided by -2. Then it will give us -1. And then we now have the x value of the turning point, which is -1. Now we are left with what? Now we are left with the y value of the turning point. Therefore, we need to take this y value, this x value that we have calculated, and substitute it back into the original equation so that we get the corresponding y value. We have to substitute back this x value of a turning point into the original, and then when you do that, you will then be able to get the corresponding y value. So it will be -1² minus 2 into -1 plus 8. And then we have to calculate, obviously, -1² will give us 1, then times negative, it will be -1, then -2 times -1, it will be +2, then plus 8. 2 plus 8 will give us 10, minus 1, it will give us 9. So it means our turning point, the x value is -1 and the y value is 9. We now have everything that we need. We have the y-intercept, which was given in our original equation as 8. We calculated the x-intercept, and then we got our x-intercept as -4 as well as 2. And then now we have just calculated our turning point, and we have now gotten -1 as well as 9. So we have everything that we need. Then it is going to be possible for us to sketch this graph. Now let us sketch our graph. Let me now erase so that I create some space for myself to draw this special graph, which is called a parabola. Please bear with me as I'm erasing so that I create some space for us to see our parabolic function. Now we are drawing, or we are sketching our graph. We are now sketching our graph. As you can see, I've drawn our y as well as the x-axis. So this is our y-axis and this is our x-axis. We have all the points that we need. Number one, let us go back. The value of a is negative. So the shape of the graph is going to be concave down. That is number one. Number two, we have already calculated the x-intercept, and our x-intercept were -4 and 2. So let us plot these points. -4, it's something that is going to be somewhere here, and +2, it's something that is going to be somewhere here. And then what about the turning points? The turning points were -1 and 9. So -1, it's something that is here, and 9, it's something that is there on top. So we have -9. And then our y-intercept, it was already given as 8. So we have now all the points that we need. Then ours is to sketch a graph that is concaved down. We just join these points and sketch the graph that is concave down. And then we also have to indicate the points with the axis. We indicate here it's 0 and 8. Here we have -4 and 0. And here we have the turning point, which is -1 and 9. And then here we have 0. We have 2 and 0. Here we have 2 and 0. So this is our parabolic function. We have sketched 2 graphs now. We have sketched the graph which was given in a vertex form, and now we have also sketched the graph which was given in a standard quadratic form. So I think we have covered at least the parts of sketching these 2 graphs. Now, what we are going to be doing now, we are going to move to a question where now we have to interpret these graphs now, these parabolic functions. Now we are moving to the interpretation of the graph. And then with the interpretation of the graph, the first graph, Mr. Ntuli will then take us through that interpretation. Then I will also come back with the interpretation of the second graph.
Wow, thank you very much, Mr. Osiane. What a very interesting and impactful presentation. Now, I am going to take you through the interpretative approach in terms of the functions grade 12. We are going to do question 2. With this question 2, we are giving a graph now. We don't have to draw a graph, but we have to interpret the graph to answer the relevant questions. So it is still on parabolic. I'm going to be quick, so just pay attention on what we are going to do now. It is very interesting. So as you can see it is more or less the same what you have been doing. So in this graph now, it's where both graph of a straight line and a parabola are given to you, then yours is to interpret in order to answer the question that follow. So we are given the graph of f at x. The graph of f at x, it is, let me erase here so that I create some space. Let me see if I work with the whiteboard versus the PDF, if it's going to allow us to have a maximum space. Because I can see that we have got a limitation when it's come to space grade 12. So I know that it will be better if we are actually using the idea hub versus both of them once. Okay, now here we are. However, with this one, we'll have to work interchangeable with the PDF. So the graph that was given to us is this one. The graph of f at x equal to negative x squared minus 4x plus 5. So I wish you can just assist me by comment to so whether you will see what I'm doing or you want us to work with one page. I think that will assist us. So if we go back to whiteboard. Why now it's not going there? Okay. The equation that is given to us, it is y equals to negative x squared minus where's my pen now? Minus 5x plus 4. That is the equation that we have. Sorry, minus 4, now I'm making a mistake. Minus 4 plus 5. And the other one, it's given by y equals to, which is g at x. Y equals to g at x equals to mx plus c. So when we look at these two equations, both of them, they are representing the function of y. And the reason why I will write y here is because g at x also represent the behavior of y at the very same time. So that's what we need to understand, student. However, working with both actually, it's kind of affecting me. I think it would be proper to work with this limited space student because I find it difficult to jump along with the board and the whiteboard. So I think it's better to stick on this one. The reason why I wanted to try the other one is because of the space that we have. So as you can see that the given equation, it is in the standardized form, whereby our A is negative, our B is negative, and our C is positive. I think Mr. Nzama was correct. What you have to do now is to interpret our function. So with that, if our A is negative, our graph will be concave down. So if our C is positive, our graph is going to shift 5 units up. And when our B is negative, our graph will shift to the left. But shifting to the left, it's also formed by the value of A because that will be our turning point. So what is it that we need to do before we attempt any question? Let us interpret and unpack this equation. So we have got f at x is equals to negative x minus 5x plus, I don't know why I like this minus 5. So because it's supposed to be positive. It's minus 4. It's minus 4x plus 5. Now, what then does it mean to us? Before we attempt that question, we should focus on this one. So what is it? Our A is negative, our graph is concave down. That's what we need to understand. So before we do anything, we need to solve and unpack all the variables that we have in this one. Mr. Nzama indicated that for us to solve here, we must actually try to make sure that our A is positive. How can we make our A positive? We can make our A positive by dividing throughout all the values by negative 1. But before we do that, as we will be calculating the x-intercept, our dependent value, which is y in this case, must be 0 because on the x-axis, our value of y is 0. Hence, we have got negative x squared minus 4x plus 5 is equal to 0. So when we divide by -1 throughout, the reason we want to find the factors in an easy way, we will be left with what? We'll be left with x squared plus 4x minus 5 is equal to 0. Now we have got a standardized equation of a quadratic equation, whereby our a is 1, our b is +4, our c is -5 equal to 0. Now we want to solve the x-intercept. So we need to factorize. If you like, yes, you can use the quadratic equation to solve this equation, but make it a point that your substitution, it is correct. Now, to factorize this, we will then find the factors using the zero rule or the zero factor method, whereby we find the factors of the first term. The factors of the first term will be x and x. Then we skip the middle term, we find the factors of -5. The factors of -5, since it is a prime number, which will be plus or minus 1. So we put 1 and 5. The signs of those factors are not the same. The bigger one must be positive. For instance, if we put +1 and -5, we find the factors. What is 1 times x? It is x. What is -5 times x? It will be -5x. But when we add these two, we will get -4x. So that's why it is important for us to make sure that our factors are correct, student. So therefore, our correct factors then will be what? Our correct factors will be then +5 and -1. Those will be our correct factors. So that's what you need to understand grade 12. So it will be +5 and -1. So when we actually multiply this, it's supposed to be -1. -1 times x, it's -x. 5 times x, it will be 5x. Now, when you add these two, -x plus 5, we will get what? 4x, which is our middle term. Now, when you solve this, make it a point that only if your leading coefficient is as it is 1, you cross substitute. So therefore, on our first bracket, we are going to say it will be x plus 5, and the other one will be x minus 1. Now, since we have got one term here, if the first bracket is 0, 0 multiplied by any other bracket or any other term, it will be 0, which will be then true for this equation. Hence, therefore, we will then say for metric x must be equal to -5. How do I get -5? I apply an additive inverse. For us to remove this 5, we need to introduce its inverse, which is -5. And what we do on the right, we must do on the left as well, so that we retain equality. So all x will be equals to 1. How do I get 1? Since it's x minus 1, we will introduce an additive inverse of -1, which is 1. Now, -1 and 1 will subtract each other because they are inversely to each other to give us 0, which is an additive identity. But what we do on the left, we must do on the right to retain the equality. Hence, our x will be 1. What then does it mean? We are going to have -5 and 0 as a coordinate. We are going to have 1 and 0 as another coordinate. So that's what we have so far after unpacking the equation that was given to us. So if we go to our graph, we can see that we have got a parabola which is concave down as it is given to us. It is clear that as we go to our parabola, if O here is a point of origin, if we go to the left, our E as the coordinate are going to be what? -5 and 0. And our P here are going to be what? Are going to be 1 and 0. We are not answering any question. We are just unpacking so that we understand what we are dealing with. Now, again, on the very same graph, we have got N there. And if we read here to say G at x equal to mx plus c are given below, points B, let me elongate here so that we can see. Points E, M, and P are the x-intercept of the graph within the x-axis and the y-axis. N is the turning point. So we don't have to try to answer any question so far. We are just unpacking the content. So here we have to address that concept to say N is also the turning point. How are we going to address that one? We are going to address that by just going back to say, how do we determine the turning point coordinate of a parabola? So we know, and Mr. Nzama has introduced us as we were busy sketching that graph to say, when we want the turning point coordinate, we can use the axis of symmetry, which is given by x equals to negative b over 2a, and also whereby you can use your x-intercept and find the average. So that is the other way we can use to determine the x-coordinate of the turning point. So in this one, how then that can be actually determined? So the x-intercept of the turning point, we are saying it can be negative b over 2a, whereby b and a are the one for the given equation, the standardized one. So let me erase this one so that we can see. Now on that one, our b in this one, the value of b, we can see that on the given one, it was -4. So it's going to be negative into, please open the brackets so that we actually don't make a mistake of that negative. It's going to be -4 all divided by, then the value of a there was -1, not 1, -1. So as we can see here, our graph has shifted to the left. We are then expecting the value of x to be negative since it's on the left-hand side of the Cartesian plane. So negative times negative of that 4 will give us positive 4 over positive 2 times -1 will give us -2. Now, 4 divided by -2 will give us what? -2. The other method that we can use, I said you can take the x-intercept and find the average. So the XTP of that graph, it will be the first x, I will term it x at A plus x at B. So our x at A, the x-coordinate of the turning point will be then given by -5 plus the other one is 1, all divided by 2 to find the average. So -5 plus 1 will be -4 divided by 2. So what is -4 divided by 2? Again, it will be -2. In order for us to get the y-coordinate of the very same point, we must substitute back this into the original equation. So our x here will be then -2, and we have to calculate y. How then do we calculate y? We calculate y by substituting back our value of x to the original equation, because I said the graph represented by y actually is the entire graph. So whatever that you do on the graph, you are affecting the values of y, and those values of y are represented in the form of a graph. So in this case, we will be then calculating the corresponding y value of -2 on the original equation. So we are saying when our x is -2, what is the corresponding y value? So in this case, it's going to be negative into, we substitute our x coordinate of the turning point -4 into -2 plus 5. So here, the mistake that we don't have to do here, or we don't have to make, the highest degree here is 2. We are not expected to multiply negative and negative before we simplify. So first thing first that we need to do here, make it a point that you simplify the brackets as applying the square there as an exponent. So it's going to remain as -1 into, so -2 all squared. Also the negative part, it's also squared. So negative times negative will be positive. 2 squared will be 4. So those are the things that we should make sure that we don't make such mistake. Now, negative 4 times negative 2, negative times negative will be positive 8, because 4 times 2 is 8, plus 5. Now, it is then correct to now affect our 4 by multiplying it by negative 1, as we are applying now the distributive property. Negative 1 plus 4 will be, times 4 will be negative 4 plus 8 plus 5. Yes, it is correct. You can just put into your calculator, but it's always important to make sure that we don't commit silly mistakes. So negative 4 plus 8 will be then 4. 4 plus 5 will be then 9. What then does it mean? It means that the corresponding y value here would be 9. Hence, our coordinate of the y of n as a turning point, it is negative 2 and 9. Now, as we are actually unpacking our graph, we can see that they said M is also the intercept. What then does it mean? M and P are intercept of the graph with the axis. So it means also N passed, the graph of G also passed there to M. So M is also the y-intercept. So y-intercept, it was also mentioned here, not only x-intercept. Mr. Nzama has indicated to us that when the graph is given in this fashion, which is y equal to ax plus bx plus c, then our c defines what? The y-intercept. So automatically, we know the value of y at m. And the value of x at m, since it is the y-intercept, again, we also know it is what? It is 0. So it's easy to be determined the y-intercept if the equation is given in the form of a standardized equation. Hence, there is no need for us to substitute or calculate if you understand that concept, to say when an equation is given in the form of y equals to ax plus bx plus c, it will be then easy to determine the y-intercept of that actual graph. So having said that, it is then correct to say to us, therefore, it will then mean here the value of x and the value of y are known at m. So what will be the coordinate? It's going to be 0 and 5. Since I've indicated that this 5 at C, it will be determining the value of the y-intercept. It is also indicated that N is a turning point on F, and NTD is the axis of symmetry of F. NTD is also the axis of symmetry of F. What then does it mean? We have indicated that the axis of symmetry will then divide our graph into 2 equal halves. So meaning that starting from the x-intercept this point, to go there to our D, here to our D, the distance from P to D must be equal to the distance from D to E. That's what we need to understand before we even calculate anything. Now, we have said that the value, the coordinate of P is 1 and 0. From the point of origin, you go there, how many units? 1 unit. Now, to move to the axis of symmetry, which is our negative 2, because the value of x here is also negative 2. It does not change vertically. It means that the value of x at D is also negative 2. Now, from 0 to negative 2, how many units do you take? It's going to be negative 1 and negative 2. Therefore, it means that the distance here, it's going to be what? It's going to be 1, 2, 3, which is an interpretative notion. Now, from here to 5, again, it's negative 2, negative 3, negative 4, and negative 5. So you can see, therefore, this one will be an axis of symmetry. What then does it mean to us? It means that at T, again, we also know the value of x there. The value of x at T, it is also negative 2. What we might not know is the value of y at that point, which is also something that we should be able to try to determine as well. So through unpacking. So the value of y here can be obtained by determining an equation of the straight line and substitute the value of x there. How then can we determine the equation of the straight line? First and foremost, we must know the gradient. And the gradient that we must obtain here, it must be positive because the graph of a straight line is increasing. So for us to calculate the gradient, we use the normal formula. The gradient of g is then equals to the equation of g, not the gradient. The gradient of g is determined by calculating the change in y over the change in x. Sorry, that's what I wanted to say. So it's going to be the change in y over the change in x, which is normally said y2 minus y1, if you are compatible with that one, over x2 minus x1. How then can we determine it? It is going to be, if we look at this point, the change in y, we have got y here, and also we have got y here. So this can be our y2 and y1. So it is going to be 5 minus 0. All divided by, we go here, it's going to be x, and this one is going to be x as well. Make it a point that the point that you started with, also on x, you start with as well. So it is going to be 0 minus, be careful again, this is -5, it's not 5, minus -5. So how to simplify this one? 5 minus 0 is going to be 5 over negative times negative is positive. So 0 plus 5 is going to be 5, which then will give us what? 1. So the gradient of this graph, it is 1. So therefore, the equation of this graph, it can be obtained by substituting the gradient, and you pick any point here, you substitute into that one to determine your equation. Therefore, what will be then your equation of the straight line? Your equation of the straight line will be then given by y is equals to the gradient, it's 1. I said to take any point between the two. For x, it's going to be, I will choose this one. It is going to be 0 plus c. Now, I substitute the value of y at that point. The value of y at that point, then it's going to be what? It's going to be 5. So if I substitute my value here, it's going to be 5. So 1 times 0 will be 0. So it's going to be c. C equals to 5. And we can see that that graph passes through the coordinate of m. Hence, therefore, our c is equals to 5. What then will be the equation of that straight line? It is going to be y is equals to x plus 5. What we were doing there, we want to determine the corresponding y value of point T. How then do we do that? We will say g at -2 is equals to -2 plus 5. So therefore, that one is going to be what now? It's going to be our corresponding value of t. So therefore, it's going to be plus 5. So -2 plus 5 is going to be 3, obvious. Therefore, our coordinate of t, the coordinate of t are going to be what? -2 and 3. So therefore, it's going to be -2 and 3. So what is it that we don't have now? I think we have unpacked all. This now we left with the point S. How then can we determine the coordinate of S? Let us look at this graph. We were told that this is an axis of symmetry, and S, as you can see, there is this dotted line. What then does it mean? S and M, they are sharing the same value of Y. So that is what we need to understand here, that they are sharing. So if that is the case, what then does it mean? It means that NTD will be the reflective of M to get S, which means M will reflect across N TD to be placed at S, as I've indicated. What is then important about the reflection? I think we have unpacked that one, that the distance of reflection of M to S will be exactly equal with that one of a reflected line. So what do I mean by that? I mean that the distance from M to this vertical line must be equal to the distance from the vertical line to S, as it will be the reflection. So those are the key things that we need to understand as we are unpacking our graphs. Also at D, it must be -2 and 0 because it's on the x-axis. I think that one will then assist us to go and attempt the question. So I want to believe we are still together because this is an interpretative question whereby it is very important to understand your working. Let us go then to our question 1. If we look at our question 1 now, what is it that I've done? Okay, I wanted to open the marks. If we look at question 1, our question 1, let me erase the space so that I'll just recall as we'll be answering. So now it is going to be easy to answer this question at a very short space of time because we've unpacked all the information that was given to us without looking at the question, because sometimes it's very difficult to try to answer the question and you don't know what is the correct answer for it. Hence, you tend to waste your time. It is always important that we're able to unpack the given information before we attempt any question. So let us go straight to our question now. The first question says, determine the coordinate of the point E and P. Ours then is to go straight to our graph. Where do we find point A? I think that one now it's easy. We have answered that one. So our point E, we calculated it. We calculated point E using factorizing and solving. So do you see that now our point E, the coordinates are known. Our point E, through that one calculation that we have done, our point E will be -5 and 0 because we have already calculated it. But please make it a point that you don't just write the answer, show all your working unless stated otherwise. Now again, the other one says determine the coordinate of P. Now, if you go back to our P, I'm going to erase that one so that we're able to see where was P. Again, we calculated the value of P as we're doing that one. Do you see now it's easy to find the coordinate of P and write them as a coordinate form as the question indicates. So the coordinate of P, I think we have indicated that one is going to be 1 and 0. So through unpacking, already we have got your 2 marks by understanding what you are doing. The other question says, calculate the value of M. What is the value of M that they are talking about here? The value of M that they are talking about here are the very same value of M that we found in a general equation of a straight line. Again, we have done that one. M here defines what? Our gradient. And C here defines what? Our constant. And we have done that one. So now it becomes easy. The value of M, we have calculated it. The value of M, which is the gradient, we calculated the gradient and we get what? 1. And the value of C, we calculated it. And what do we get for the value of C? We got 5. So that's how easy if you start by unpacking the given information before you attempt any question. Now, number 1.2.3, calculate the length of NT. The length of NT, it is this distance. This distance now can be calculated in 2 ways since we have unpacked that one. And I'm going to try to make sure that we work on this one together. How one can then calculate what we call the length of NT. If you haven't calculated the coordinates, The length of NT, N it's on the parabola, and T is on the straight line, as our information is indicated. T is a point on the graph of G. Now, they indicated that NTD is an axis of symmetry. What then does it mean? It is a vertical line. How then can we calculate the distance of a vertical line? Our focus must be on the values of y. Why? Because to find the length of this distance, the greater value of y at a turning point minus the greater value of y at a lower point will be giving us this value as the length. Now, I'm going to do it in this way so that we all understand. The first one is the one that we know the coordinate. So the distance of NT can be obtained by y at turning point minus y on a straight line, because we know the values. Y at a turning point, as we all know, it was -2 and 9. It is going to be 9 minus. What is y on a straight line here at t? We calculated and we found what? 3. Therefore, the value after we have shown all the calculations, how you got 3 here, how you got 9 there, it is going to be 6 units, because 9 minus 3 is going to be 6 units. Please don't forget to write the units since you are working with the distance. Now, let's say you have not find 9 and 3 on your working as you were unpacking. The other method that we can use is to say the upper function minus the lower function, because I've said the function represents the value of y. So the graph, each and every graph represents the value of y. How then that can be done? So the distance of NT, it will be then determined by saying the top y, which is a parabola. Therefore, what we are going to say, we are going to say top y in the form of its equation, negative x squared minus 4x plus 5 minus the straight line, because the straight line is at the bottom. Now we know the value of m, we know the value of c. Minus, please put the brackets or parentheses, since you will be subtracting more than one term. It was 1 x, because the gradient was 1 that we calculated, plus 5. So with this one, then you simplify. So it's going to be negative x squared minus 4x plus 5. You introduce negative, it's going to be negative x minus 5. Grouping the like terms will be negative x squared. And when you look at this one, negative 4x minus x is going to be negative 6x. Then you take out the common, we group the like terms. 5x and this one will also give us what? Will give us 0, because these are the like terms. This one, it is an equation, general equation of this line, learners. It is general equation of this line. Now, what we need to understand, we need to understand that what then was the value of x at that point? It is very important to understand that one. So it will then assist us to calculate the value, the distance of this one. Now, the value of x at this point, we have alluded that it is -2, because there it does not change. That's what we need to understand. So we know the value of x there. So therefore, what we need to do then, it is important for us then, since we know the value of x, since the value of x vertically does not change, ours then will be then substituting into the correct formula. So please don't make mistake on that one, so that we will get our solution the way we want it to be. So it is very important on that one. So this one. Oh, sorry. Here it's supposed to be -5, not 6, because -4x minus, yes, it is -5. On that one, so what then we need to do, we need to substitute our value of x because we know it. But if we didn't know, we are not on that one. We will see next time when we are dealing with a calculus, how do we solve this one? But for now, we will just apply the straightforward notation. So on this one, we will then substitute. So it is going to be negative into negative 2 all squared plus, minus 5 into negative 2. Which will be then, again, don't make a mistake of distributing this negative before you simplify. It's supposed to be negative 2 all squared times negative 1, which will be negative 4 plus. So negative times negative is positive 10. So therefore, negative 4 plus 10 will give us what? Will give us 6 units, which is exactly the same what we got if we say 9 minus 3. So these are two methods at least that we can use now to solve this one. But the calculus one, it will come when we are doing a calculus whereby we'll be dealing with the first derivative to find that one. So the other question, it says, determine the coordinate of the point S. Now, the point S again, as I've indicated, it is there on the parabolic graph. But I set this dotted line. It means the value of y here does not change. I think I've actually explained that one. So please be careful of that one. Now, what do we have? We have got the coordinate of m, which is 0 and 5. So the coordinate of m must reflect across the line that is vertical. What did we say? We said that this line is a reflective line. This point, as it jumps over, the distance from here to here must be equal to the distance from here to here. That's what we need to understand. That's how it's easy to actually get this point. What then do we need to do? We know that the value of x here is 0. So which means if we move from 0 to the left, how many units? It's 2 units. So which means from here to here, again, we must move how many units? 2 units as well. So if 2 units here and 2 units here, we are saying here the value of y does not change, which means what is y here will be y here. So the coordinate of this one, again, from 2 units to 2 here, the distance, we all understand that, therefore, x here at S must be 4. Then the value of y does not change since it is a horizontal line. It is going to be 5. So that's how easy we can calculate the coordinate of m. Okay? I want to believe that now as I said, the distance from M to the axis of symmetry is equal to the distance from the axis of symmetry to S, because this is reflecting across the axis of symmetry. Now, what is the coordinate on the axis of symmetry? On M, it's 0 and 5. So this distance will move from here to here. How many units? 2 units, because it's negative 2, x does not change. Now, from here to there will also move how many units? Again, 2 units. So since we are going to the left, therefore the coordinate of S must be negative 4, and 5 does not change because the line is horizontal, will be supposed to be 5 as well. So I want to believe that one, it will be easy as long as you understand this transformation. Again, our next question, we were asked to calculate the values of x for which f is decreasing. So for which values of x where f as a graph are decreasing. So ours is to go back to our graph. From left to right, that's how we interpret. And the graph of f is given by the parabola. How will we then answer that question? That question, it's very easy, grade 12. So that question, it says, we are moving from left to right. What values of x will then make the graph to decrease? If we go back to our turning point, because that's where your graph will change from decreasing to increasing, from increasing to decreasing. The value of x there is -2. So as we move along the x-axis until -2, what is happening to the graph? The graph of a parabola, which is f, is increasing up until it reaches the turning point. At a turning point, the graph will be stationary because that's where the gradient of a tangent will be equal to the gradient of that function. After the turning point, the graph will start to go down. What then does it mean? It will increase up until it's x equal to -2. Then it stops there. Then it changes its direction. After that, the graph will go down. So therefore, from -2 up until infinity, our graph will be going down, grade 12, because before -2, our graph was increasing. How then do we write that answer? We are saying it's when x is greater than -2. All those values will make the graph to decrease, because decreasing defines by as x increase, what's happened to y? Y is decreasing. So that's what it means by this question, which is 1.5. And then, what is the range of the graph of f? Range of the graph of f, as we all know, these will be all possible values of y. So all possible values of y on a graph, what do we need to consider here, grade 12? You must make sure that you interpret your graph correctly from the starting point to the ending point, because sometimes our graph will be ending somewhere. But because of these arrows, what then does it mean? Our graph will go negatively infinitely as x goes negatively infinite. But as also x goes to positively infinite, our graph again is going down. That is the meaning of these arrows. But our graph, when you go up, our graph will end somewhere. What was the maximum value that the graph has? It is 9, because y, actually the coordinate of the turning point was -2 and 9. How then do we write the range? You start from the smallest value to the greatest value. So we are saying we go down negatively infinite on y values as the graph, the arrows that are pointing downwards. So to answer the question then, how do we present that one? We are saying the range of the graph will be given by all possible values of y on a function. Now, what are the possible values of y on a function? So the values of y that will be actually real for this function will start from -infinity up until the maximum value. And the maximum value of this graph, it is +9. So the range will be y is an element. We don't include negative because negative is a symbol, it is not a value. From -infinity until as it goes up, the maximum value that the graph has will be +9 included. So be careful of that one. So this is how we can put our notation. Alternatively, it can be expressed as y is greater than -infinity, but less than or equals to 9, because it ends exact at 9. So 9, it is included. So please take note of that one, grade 12. The other question that we need to answer again, it says, for which values of x is f at x, which is y, is greater or equals to g at x, which also defines y. Now, what then does it mean? We are saying, what are the values of x that will make y of the parabola to be above than y of a straight line, which is g at x. So that is the question. Or they are equal. So that equal sign, that smaller line, it means small line, it means they are equal. What then does it mean? We go to the point of intersection. First, we are identifying where are these two graphs meet. So that will be our starting point. So if we go back to our graph, we will look where the graphs are equal. So where the graphs are equal, they are equal at E, and they are also equal at M. We know the coordinate of E. The coordinate of E was -5 and 0. The coordinate of M was 0 and 5. So that's why the two graphs are equal. But f at x must be above than g at x. If we go to the left, g at x is above f at x, which means all the values that are less than -5, we will make our g at x to be above f at x. If we go to M, g at x is above f at x. Again, if you go beyond 0 for x, all the values of a straight line in y will be greater than the values of a parabola of y. So therefore, our solution, it means that it must be between the two. As we can see here, the parabola here is above up until the point of intersection, whereas the straight line will be always below at that interval. So therefore, that's how we then must answer the question. So how do we then present that question? We will be saying, for the values of f at x to be above the values of a straight line, that will occur when the values of x are greater than -5, but those values must not be greater than 0 because x is 0 here. So this is how we express it. We are saying x must be greater than or equals to -5 because they are equal at that point of intersection at E. But the very same values that are greater than -5 must not be greater than 0 for x here, because after 0, the values on a straight line will be greater than the values on a parabola. So therefore, they must be less than or equals to 0. Saying that, we have answered the question to say all the values that are between -5 and 0 will make the graph of a parabola to be always above the graph of a straight line. So hence, we have answered the question. Having said that one, I think that was our last question on this interpretation of the graphs. So I think it is correct for me to call my partner in crime, Mr. Nzama, to just say the wrap-up, actually, submission to this wonderful session. Thank you very much, Mr. Nzama.
Thanks, Mbamba. Good evening once again. We have only 7 minutes left, so I think it would be proper for us just to recap on what we have done today, because I don't think time will allow us to even finish the other question that we have prepared for you. So today we have looked at parabolas. We have sketched parabola. We have also tried to interpret the parabola. So, as I said, we had already prepared a nice question for you, but then unfortunately, the time does not allow us to even start. So, what we did today, we were able to sketch the parabolic function, which comes in a standard form, in a form of ax squared plus bx plus c, where we said the value of c, our constant, is the y-intercept. What we have also discussed today in our class, we have also said we know when we are looking for the x-intercept, if you are given an equation in this standardized quadratic form, we know that for the x-intercept, y will always be equal to 0 because the x-intercept is found on the x-axis. So what we then do, we just equate to 0 and then we factorize and solve for x, and then we get our x-intercept. And then we also said if our equation is given in this form, to get the turning point, we use the equation of symmetry, which is x is equal to minus b over 2a. And then we substitute the value of b as well as the value of a, and then we get our x value of the turning point. And then after that, we take the very same value of the turning point x, we then substitute it back to the original equation, and then we are able to get the y-intercept. We then also looked at sketching the graph of a parabola where you are given an equation in a vertex form, where we said the vertex form or the turning point form will give you the coordinates for a turning point. So you don't calculate a turning point for that one. We did the equation which was in this form, y equals to x plus p all squared plus q, where we also indicated that p and q represent P represents the horizontal shift when you are shifting left or right, and then Q represents the vertical shift. It's when we are shifting up or down. And then we know that when Q is greater than 0, then our graph will shift vertically upwards. But when Q is less than 0, then our graph will shift downward. So it is very important to take note when you are given this equation in this form, the value of Q, whether is it greater than 0 or is it less than 0. So when it is greater than 0, then your graph will then be shifting upwards, and then when it is less than 0, it will be shifting downwards. And then we also set the value of P. When you have this part x plus p, we then equate it to 0 and solve. Then the value of p tells us about the horizontal shift, whether the graph will be shifting left or right. And again, when p is less than 0, it means our graph, when p is negative or less than 0, it means our graph will shift to the right. So when p is less than 0, our graph shifts to the right horizontally. But then when our p is greater than 0, so when our p is positive, then the graph shifts to the left. So as much as P and Q are our turning points, but they also represent the horizontal as well as the vertical shift, because the turning point actually it's supposed to be at the origin, as we did indicate in our at the beginning of our lesson. We did indicate that then if the graph has now shifted downwards, then it means Q has affected the graph, and then P as well has also affected the graph. So this is what we have done for today. We also went through the interpretation of graphs, but we were just focusing on the interpretation of a parabola for today. And then we spoke about the axis of symmetry, which we said it is the line that cuts our graph into symmetrical parts, into two symmetrical parts. And then we said our equation of symmetry, if we have our parabolic function, then we know that we have this line. If we have a turning point, then this value here, if it's -2, then it means our equation of symmetry is -2. And then we said that this line will then divide or cut our graph into two symmetrical parts. This was just me trying to recap on what we have done. We have also spoken about where our graph, because in our parabola, it's very important to know where it is decreasing. As you can see, when you are reading this graph from left to right, you can see that the graph is decreasing until it reaches a point, a turning point where it's stationary, and then it starts increasing. So it's also very important to take note of where our graph is decreasing, how the graph is behaving, where it is decreasing and where it is increasing. Also to take note where our graph is positive and where our graph is also negative, because when we're talking about our graph, we are focusing on our y values. We know that below the x-axis, our graph is negative. Below the x-axis here in this region, this is where our graph is negative, which is below the x-axis. And then above the x-axis, it's where our graph is positive. So in our next lesson, obviously, we are going to continue with interpretation of graphs. We're also going to go through our hyperbolas as well as exponential graphs. The time now is 7 o'clock. It should be the end of our lesson. Let me also invite our students to please make sure that they do fill in that register for those who have not done it. Tomorrow, we are also going to be having a physical sciences class. Please make sure that you log in around close to 5 so that when the lesson starts at 5 o'clock, you are also going to benefit. Thank you very much. Until you see each other tomorrow or in the next time. Bye-bye.